Use and maintain measuring equipment by Kim Middleton and Jesse Riles.
Before using the vernier gauge, always ensure that the measuring surfaces are clean. Do this by wiping the surface with a finger or cloth, and then closing the gauge and ensuring that the gauge reads 0.
Verniers measure both metric and imperial. They have two sets of numbers on them for each unit. The set on the main part and another set on the slider for precision measurements.
To adjust the position of the dial gauge, loosen the clamps and slide the gauge along the bar to the desired position, then retighten the clamps.
Make sure that the needle is halfway through its measuring stroke so that it can take a positive or a negative measurement. Once the needle is up against the surface to be measured, always zero the gauge.
To check the calibration of a micrometer, clean it and close the jaws down against each other lightly and check that the gauge reads 0. If the micrometer range doesn't start at 0, for example 25mm to 50mm, put the appropriate calibration bar in between the jaws and close them onto that.
To clean the micrometer, close the jaws together on a piece of paper and then pull out the piece of paper, removing any dirt or grime from the contacting surfaces.
To clean an internal micrometer, use a clean rag and wipe the contacting surfaces of any grime or small particles. To measure deck warpage, place the straight edge diagonally across the block. Then using a feeler gauge, measure the gap between the straight edge and the centre of the block. Repeat the process on a 90 degree to the last check.
Hold the sleeve firmly inside the block with 2 bolts. Then using a straight edge across the face of the liner, measure the gap between the face of the block and the straight edge with a feeler gauge. To measure bore diameter, use an inside micrometer as shown. Don't forget to add the length of the extensions into the final measurement.
To measure liner taper, use a cylinder gauge that is set up appropriately for the diameter of the bore to be measured. Before measuring, ensure that the needle is halfway through its stroke so that it can take a positive and negative measurement. Take 3 measurements, one just below the unworn ridge at the top, one in the centre and one at the bottom of the bore. Don't forget that you have to subtract the measurement from the overall length of the extensions, not add it to the overall length.
To measure the cylinder ovality, use the same process but repeat it in a 90-degree angle to the first set of measurements.
Visually inspect the crankshaft for any scores, heat spots, cracks or wear marks.
Using a pair of vernier calipers, measure the diameter of the crankshaft journal on both sides of each journal.
Using a micrometer, measure the diameter of the crankshaft on both sides of each journal and then repeat the process 90 degrees to the first set of measurements.
To measure for a bent shaft, place the crankshaft in a set of V-blocks and set up the dial gauge as explained earlier. Turn the shaft and record any deviations.
To measure the camshaft lift, first measure the width of the lobe surface as shown in the picture with a pair of vernier calipers.
Then turn the camshaft 90 degrees and take the measurement again. Subtract the width of the lobe from the width of the lift side and this gives you your total lift.
Place the telescoping gauge inside the camshaft bushing and loosen the handle to take the width of the bushing, then retighten the handle and measure the length of the telescoping gauge with an external micrometer. To measure the piston diameter, use a micrometer to measure the width of the piston skirt. Then to measure ovality, repeat the process at a 90 degree to the first set of measurements.
Find the appropriate feeler gauge to fit in between the gap of the piston ring and the groove as shown in the picture. Using a pair of verniers, place the end of the vernier on the piston as shown in the picture and then slide the needle into the groove until it bottoms out on the groove and record the measurement. Piston rings should be evenly spaced around the piston with the gap away from the thrust sides. The thrust side is the side that the conrod pivots towards.
Obviously the bearing in this picture is the wrong size bearing, but for the purpose of the exercise we have exaggerated the measurements. Bearing crush is where the ends of the bearing sit above the top of the cap, and bearing spread is where it's more semi-elliptical as opposed to a semicircle, and therefore doesn't quite touch the bottom of the cup until the bearing cap is tightened.
To measure the side clearance of the oil pump gears, find the appropriate size feeler gauge that fits between the pump gears and the housing that the gear runs up against as shown in the picture.
To measure the end clearance in the oil pump gears, place a square across the face of the housing and then find an appropriate size feeler gauge that fits in the gap.
To measure the oil pump gear backlash, find the appropriate size feeler gauge to fit in between the 2 gears in mesh as shown in the picture.
To find flywheel warpage, use a straight edge across the face of the flywheel and measure any difference in gap between the flywheel and the straight edge.
Visually inspect the flywheel for any evidence of heat spots such as discoloration, any wear or damage, scoring or rounded or chipped teeth.
To check the drive lug for squareness, use a tri-square up against the lug as shown in the picture and check for squareness. Repeat this 4 times 90 degrees apart for the most accurate outcome. To measure the axial run out of the flywheel, place the dial gauge on the block or bell housing and put the needle on the flywheel as explained earlier. Rotate the flywheel and record any deviation. To measure the radial run out, just use the same procedure as the last slide, only with the needle on the outside of the flywheel as in the picture.
Set the selector to the appropriate voltage range and plug the connections into the correct socket, the black connector into the common port and the red connector into the volt port. Place the red lead on the positive terminal of the battery and the black lead onto the negative terminal of the battery.
The Tech2 computer can be used to diagnose engine faults and codes and help gain better performance of an engine. The usage of a Tech2 computer should be left to a trained technician who knows what they are doing, as some settings can be changed that will be detrimental to the engine's performance.
Most Commodores have their Tech2 connection above the driver's side footwell, but it can also be found on some vehicles above the passenger side footwell.
Types of measurements that can be seen through the Tech2 computer are engine coolant temperature, intake air temperature, and engine speed.